Algebra 2 Regents, state sample question number 8. This video is actually going to cover 8 and 9. But first, number 8. The results of a poll of 200 students are shown in the table below. So this table is comparing gender, male and female, versus preferred music styles, techno, rap, country. And what we want to know is for this group of students, do these data suggest that gender and preferred music styles are independent? Now, independent basically means they have nothing to do with each other. That the knowledge of one doesn't affect the probability of the other. That if if we take one of the 200 students at random, and given that it's a male, does that affect the probability that that student might like techno, rap, or country, kind of thing? Or given that a student likes techno, does that affect the probability that your student is male or female? So we have a simple test for independence, and the test for independence is that if the probability of event A times the probability of event B, if that is the same as, so if that equals the product of their probabilities, if that's the same as the probability of A and B, if that is equal, then these events are A and B are independent and they have nothing to do with each other. Well, let's look at this. Now, does gender and preferred music, are they independent? Well, what we can just do is look at one example here, like female and techno. And if they're not independent, then the answer is no. If they are independent, well, then we probably need to look at all the other scenarios, female rap, female country, male techno, male rap, male country. And if everything's independent, then, so if everything comes out equal, then gender and preferred music styles are independent. But let's look at our first example here. So we want to test that if you pick a student out of these 200 at random, what's the probability the student is female? And so the way to do that is we need to know how many females there are. And so this is one of the tables that doesn't give you a total. Sometimes they add in a total for everything here. And the total is there, but sometimes we also have the total here. So this is one of those cases where you need to kind of calculate these totals. And so a calculator would be helpful here to help us do this math quickly. So I'll take my calculator out. I also have a calculator here on the side. So while that's loading, maybe I'll just type this first one in for us. So for female, there's 54 female that like techno, 25 that like rap, 27 that like country, a total of 106 females. For the males, that means that there's going to be 94. Because there's a total of 200 students surveyed. But let me double check that. 36 plus 40 plus 18 is 94, so that's good. And then if we want to do the totals for how many students like techno, 54 female, 36 male, total of 80, 90 students like techno. This would be 65 like rap, and 1827 is 30, 45 like country. And again, this also adds to 200. So the probability that a student is female, probability at random, if we take a student, pick a student's name out of a hat, out of the 200, the probability to get female is 106. There are 106 females out of 200 possibilities. And the probability that out of the 200, you select somebody who likes techno. Well, there are a total of 90 students out of 200 that like techno. What is the probability if a student is selected at random out of the 200 that the student is female and likes techno? And that probability is there are 54 females that like techno out of the 200. And so what we need to do is test to see if these individual events, if the product of these two things, female times techno, if that equals female and techno, then they are independent. So that's going to be 106 over 200 times 90 over 200. Does that equal 54 out of 200? I think my calculator's ready, so we can use this here. Minimize that for a second. 106 divided by 200 times 90 divided by 200. And you could use parentheses, but because it's all multiplication and division, it's okay not to. We have 0.2385. Is that the same thing as 54 divided by 200? The answer is no. So we get 24 versus 27. So 0.24, and that does not equal 0.27, not equal. So the answer is no, not independent. And they say justify our answer. We just did. We did the math. Whenever it says explain or prove, that's where we need to write a couple of sentences here. Justify, math can count as your justification. So we could justify it further by then say, all right, how about female versus rap, and the probability of a male versus the probability of rap, the probability of male and rap, and I'm guessing it will come out to be no because gender and preferred music styles are not independent. They do have something to do with each other. All right, so that's sample number 8. Let's move on to number 9. For the function f of x equals x minus 3 cubed plus 1, find f inverse. Remember that, f is the name. F is not a variable. X is a variable. F is the name of the function here. And when you have this little -1 symbol above it, it's not an exponent. It is a symbol for the word inverse. And the thing to always remember about inverse is switch x and y. That's what inverse really needs to mean to you. We tend to say opposite, which can be true, like the inverse operation of addition is subtraction. But always try to remember that inverse. When you see that word or that symbol, think switch x and y. So the way to do an inverse function or an inverse equation is to switch x and y. So first of all, this equation, I want to, instead of writing it in the function notation f of x, I want to write it as the y equals notation. So y equals x minus 3 cubed plus 1. And the first step to doing the inverse is switch x and y. So change it to x equals y minus 3 cubed plus 1. Everything stayed exactly the way it was, but I reversed x and y, switched x and y. But that's not just that. We also like to get it in the notation where y is alone, like we have here. So now I need to rearrange this so that this y is by itself. So the first thing is this plus 1 on the end. I can move that over, make it x minus 1. We always look for the easy plus or minus stuff to do first. It's reverse PEMDAS is really what we're doing. And then I need to work with this parentheses, but before I get in there, I have to deal with the outside. This exponent is a 3. It's being cubed. So the inverse operation of cubed is cubed root. So I got to do the cubed root of x minus 1 to undo that to y minus 3. And then lastly, now I can move that plus 3 over, but that is not going to be in the cubed root piece. So x minus 1, and then outside of that will be a plus 3 equals y. Or now I can set it equal to the f inverse of x notation now that y is alone, either way. And so that's the answer here. There's a nice little calculator trick we can do to check this, because if you remember what switching x and y, it's the same as reflecting over the line y equals x. Y equals x is just a perfect diagonal line through our graph here. So if we see a mirror image across this line, that's a sign of inverse operations. So we'll type in the original x minus 3 cubed. Shortcut to cubed is math 3, or you could use your exponent key. Plus 1. And then let's also type in the cubed root. I don't need the second key. I got to go in the math folder here. Choice 4 is cubed root of x minus 1. Make sure I get out of that cubed root piece before I do a plus 3. Because remember, there's a big difference between inside and outside. That's your transformations. Like this minus 1 inside means right 1, but the plus 3 outside means up 3. So there's a big difference between inside and outside. Same thing here, like this minus 3 means right 3 versus up 1. And let's look at all this stuff graphed together. So we have the line y equals x. Next, it's going to graph the cubed root function in red, and then it's going to the cubed function, and then the cubed root. So the red is f of x, and the black is f inverse of x. And again, we see they are a reflection of each other across the line y equals x. You could take a look at the table, and you might see some interesting things at the table. I think the table can be a little confusing because you're going to see the inverse of x and y, but so maybe the table isn't too helpful to you. If you understand what it's showing, you can kind of see inverse relationships. Like instead of let me get a simple point here to show you what I mean, why the table might be helpful. Like here, 3 1 versus 1 3. You know, this first one is just y equals x, so ignore that. But 3, 1 for the original, where the new one has 1, 3. Every x and y have been switched. But I think the visual reflection is very, very helpful. And the way we do that is we switch the x and y's, and then we do the inverse operations to get y alone. So it's a big algebra question. Here, it's just knowing this formula and testing some probabilities out. All right, so that's sample 8 and 9. See you later.